Welcome to On the Other Hand, and a special welcome to these new subscribers and any other new viewers. And also a special thanks to Carson. He's a cool guy who did this new background and does news-related political videos. I'd highly recommend going and checking out his channel. And he also doesn't believe in intellectual property, so I'm not saying I would condone someone copying all his videos and reposting it on a clone channel for kicks, but if someone did, I'd subscribe. I've wanted to cover climate change since I started this channel, so I'm finally doing it. To start off, let me cover some useful facts for this conversation, namely temperature and CO2. Then I'll dive into scientific consensus, then climate versus weather, and finally, what we can do about it moving forward. And so you know my bias going in, I'm an American conservative. First, here's a graph of the temperature record for the Earth. For dates far past, the data has been reconstructed based on measurements taken from ice cores. Zooming into the current era, here's a graph from NASA covering the land-ocean temperature index from 1880 to the present day. This index uses the years 1951 to 1980 as a baseline for the graph. Similarly, let's look at a graph of carbon dioxide record over the history of the Earth. This, from what I can understand, has also been measured from ice cores. Here you can see our first-hand recordings of CO2 from NASA. The way NASA measures CO2 is from space. A satellite can measure the infrared spectrum emitted from the Earth, and based on these spectrum emissions, we can tell what chemicals are present in the atmosphere and in what quantities. It's really cool stuff. If you want to learn more, links to all these materials and the data are in the description below. Anyway, we speak of carbon dioxide specifically because it's the most directly tied to human behavior and to the greenhouse effect. And also, here's a breakdown of what sector these emissions come from according to the EPA. So now we've covered some groundwork, let's dive into the hot takes and controversial stuff. Starting with the scientific consensus and the Cook study. Here's a clip from a channel called It's Okay to Be Smart introducing the topic.
97% of climate scientists agree. Humans are causing global warming. It's one of the most famous statistics in all of science that experts, the people who know the most about Earth's climate, agree almost universally that humans are warming the planet. Where does this 97% number come from? The most famous source of the 97% agreement comes from a study in 2013 by Australian scientist John Cook. He looked at almost 4,000 scientific papers that made some statement about whether humans were the main cause of climate change. And 97% of those papers agreed with the consensus. To make sure nothing was misinterpreted, he also asked scientists to rate the views of their own papers, and they found the same 97% agreement. It shouldn't surprise you to learn that people have attacked this study, saying its methods were wrong, that it miscounted things. But even if we ignore Cook's study, turns out lots of other people have looked at this question and found a similar answer.
So, that's one side of the argument, and here's a clip from a channel called the Climate Discussion Nexus for the other side of the argument.
Another survey appeared in 2013 by Australian researcher John Cook and his co-authors, in which they claim to have examined about 12,000 scientific papers related to climate change, and found that 97% endorsed the consensus view that greenhouse gases were at least partly responsible for global warming. This study generated headlines around the world, and it was the one to which Obama's tweet was referring.
But here again, appearances were deceiving. 2/3 of the papers that Cook and his colleagues examined expressed no view at all on the consensus. Of the remaining 34%, the authors claimed that 33% endorsed the consensus. Divide 33 by 34 and you get 97%. But this result is essentially meaningless because they set the bar so low. The survey authors didn't ask if climate change was dangerous or, quote, man-made, unquote. They only asked if a given paper accepted that humans have some effect on the climate, which, as already noted, is uncontroversial. It could mean as little as accepting the urban heat island effect. So, a far better question would be, how many of the studies claimed that humans have caused most of the observed global warming? And oddly, we do know, because buried in the author's data was the answer, a mere 64 out of nearly 12,000 papers. That's not 97%, it's 1/2 of 1%. It's 1 in 200.
So some people say 97% of climate scientists agree, and others say it's 1/2 of 1% of all scientists. Go figure, people are using statistics to frame the question and answer in a way that sounds convincing. So, let's look at the actual study in question. The introduction to the study says after, quote, examining 11,944 climate abstracts from 1991 to 2011, matching the topics global climate change or global warming, we find that 66.4% of abstracts expressed no position on global warming, 32.6% endorsed global warming, and 0.7% rejected global warming, and 0.3% were uncertain about the cause of global warming. Among abstracts expressing a position on global warming, 97.1% endorsed the consensus position that humans are causing global warming. So, which interpretation is more accurate? I'd highly recommend looking into both videos I've showed clips from, as I think they do a good job speaking for themselves. But before I leave the subject, I would like to touch on the idea of survivor's bias. Here's a clip explaining the subject from a channel called Veritasium.
Welcome to the Bukchon district of Seoul, South Korea. It is here where you can find some traditional Korean architecture, these really impressive roofs. And looking at these buildings, it might be natural to conclude that, well, they just don't make them like they used to. That in the old days we used to build with much better quality. But there is a question of, is that really true? Because we're not looking at all the homes that existed back then. We're looking at a select subset, that group that has survived to the present day. So you would say that it'd be pretty logical that these homes would be the best built and the best maintained, so they don't really give you an idea of the way things were built. And we get that same impression for a lot of things. So this is known as the survivor bias, and it comes into play with a lot of our reasoning where we're looking at samples which are not complete. The classic example of survivor bias comes from World War II, when the British were losing so many bomber aircraft when they flew over occupied territory. They were shot down so often that the British decided something needed to be done. They needed to add armor to these aircraft. So they did a survey of all the planes that had come back, and they noted down where those planes had been shot. And then the thinking was, well, you just add the armor there where the planes are getting shot, and that should help protect more planes. Of course, this is a terrible idea because the aircraft that you're looking at are the survivors. They're the ones who have made it back to you. It's the ones that you don't see. Those are the ones whose hits you need to protect against. But how are you to know where those aircraft were hit because you never get to see them again? The ones that are coming back to you are getting hit in places that are not vital, that don't cause them to crash. So the places where they're not getting hit are the places that need the armor.
So the Cook study we just looked at examined abstracts that match the topics of global climate change or global warming. The question I would like to put forward is, what kind of bias does this impose? In some ways, this means that you should be getting relevant studies to analyze. But much like the building shown at the beginning of the clip, how many climate scientists would stick around and continue to produce papers if they play down or don't speak out strongly about climate change?
Food for thought.
Now on to the next climate subject, where I want to discuss climate versus weather. And here to kick off this section is a video from the Vlogbrothers.
Here's what we all need to get, and I don't think it's anybody's fault for not getting this. When we talk about the effect that a warmer Earth will have on the weather, we're not talking about what's gonna happen. We're talking about what's probably gonna happen. Or more properly, the probability of what will happen. We are never going to know how many big storms are going to hit the US in any given hurricane season. But we can take a look over the last 50 years and see how many major storms formed per year. And I'm doing that right now. I'm putting a dot for every year. Most of the years had 2 storms. Some of them had 5, some of them had 4, some of them had 0. That year with 7 storms there, that was 2005, the year that Hurricane Katrina hit New Orleans. All right, yeah, you see what happened here. There is a curve. This is a probability distribution, and it is always how we should be thinking about how a changing climate is affecting weather today, now, this year. Not the dots. The curve. Every year at the end of the hurricane season, this probability curve collapses into just another dot. It is no longer a set of things that could happen. It becomes a very specific thing that did happen. Last year, it collapsed into 4 major storms. The year before that, 2. The year before that, 2 again. And the year before that, 0. Do we have a trend happening here? No. This is not a trend. Every year, the curve runs itself again, and it might collapse down to 0, or it might collapse out to 7. Like, look at the dots. Obviously, no one dot on this curve is important. And also the curve is saying that all of this stuff happens. Everything that's in here is well inside of the realm of normality. The number of serious storms from year to year can jump dramatically while being the effect of the same probability curve. A warmer planet doesn't take you from this to this, because global energy in the system isn't the only important variable. It takes you from this to this. Something important is changing, and that's shifting the curve. When that new curve collapses into its reality dot, that might still be at 0. It's just less likely than it used to be. And years like 2005 will still be rare. They will just be less rare. And if there are more strong storms, there's a higher likelihood that they'll end up hitting in the worst places possible, as Harvey did, as Katrina did. Homes that used to be considered safe might now find it difficult to get insurance because no one understands probability curves like the people who work at insurance companies. And these probability curves are what we use to determine whether a flood has like a 1 in 100 chance of happening or a 1 in 50 chance of happening. And as that changes, those 100-year floods start to not be 100-year floods. And the curve can shift before we're aware of it. Like with this, we only get one new dot a year, which is why we create computer models so that we can run hurricane seasons over and over and over again with slightly changed variables to see what will happen. And what we see with more energy in the global system is the curves shifting towards stronger, wetter storms. The more carbon we release into the atmosphere, the more these curves shift. And that is the future that we have to accept and the one that we have to prepare for.
Those on both sides of the argument often attribute specific weather events to climate change, be it extra snow in the winter or extra bad fire in the summer. Statistics aren't that easy. These are all probabilities of what might happen, not causal relationships explaining current events. Here to emphasize that fact is a clip from ABC.
The wildfires here on the West Coast are turning into a political football. Democrats blame the fires mainly on climate change. Republicans blame it on forest management. It's starting to turn into a debate, as though one of these two things were the right answer. That's bonkers. I've investigated and reported on wildfires across the West for almost 2 decades, and our problem is not climate change versus forest management. It's both of these problems happening together. That's why fires are killing more people. You need 3 things for fires to burn. You need fuel for burning, heat to light it, and oxygen. You're looking at what firefighters call the fire triangle. Take away any one of these things and you can't have fire. Putting climate aside for a moment, California and most of the West has a fuel problem. Better forest management can reduce the danger. We've put out every fire we could for almost 2 centuries, eliminating the natural fires that used to clean up the forest floor. Today, a lot of it's overgrown. To thin it out, we can either let parts of the forest burn on purpose when the weather's safe, or cut out crowded trees and undergrowth. Our forest problem is a bonfire pile. The climate problem works more like a bad luck charm. Scientists expect on average we'll get more days every year with bad fire weather. That hits all 3 ingredients. More hot days, more dry days helping fuel burn, and more windy days blasting wildfires with rushing oxygen.
So you can easily look at trends in numbers of forest fires or hurricanes over a cherry-picked time frame or area to get data that will back up your worldview. But simply attributing bad things to climate change or cold weather to a lack thereof is silly. Why is climate change so contentious a topic? Because the ultimate questions are, what do we do about climate change, how effective will the mitigation be, and what will it cost? In order to judge these things, we need to look at the current projections. According to this IPCC report, the most likely scenarios say that by 2100, the global temperature will be on average 1.1 to 3.1 degrees Celsius, or 2 to 5.5 degrees Fahrenheit, warmer than we currently are. Here's a nice graph that shows current projections and likely outcomes, all looking towards the most likely outcomes with different actions. So according to these estimations, the difference between current policies playing out over the next 80 years and an optimistic net zero target is the difference of 0.5 degrees Celsius, or about 1 degree Fahrenheit. Then we might look at who is most responsible for these emissions. Here is Wikipedia with some useful statistics. By total emissions, the top countries are China, the US, the EU, India, Russia, then Japan and Germany. Of those, you can see that each country has been gaining or cutting emissions at different rates, notably that China and India have been the biggest areas of increased emissions, and the EU, Russia, and Germany are on the decrease. And if you look at emissions per capita, the US leads these countries, followed by Russia and Japan. Sorting it in this way shows the highest culprits of emissions, but if sorted by per capita emissions, you get this view instead, that tends to focus on smaller countries. So, improvement from all the countries is needed, but how should we go about encouraging or enforcing improvement? Because I'm from the US, I happen to know that the fracking business has been on the rise in the US, which has done a great job replacing coal. And it turns out that natural gas burns a lot cleaner than coal, so the US has been emitting less since about 2007. So is natural gas an answer to decreasing emissions? Some say any improvement is worthwhile, others say it does more damage than good. Electric cars are also a good move, as it doesn't directly burn gasoline but instead off-puts the emissions onto the electric grid. This then presents options for lower emissions in transportation by adapting the power grid, and one of these options is nuclear power. Nuclear produces no greenhouse emissions to generate electricity, but it does produce small amounts of high concentration radiation waste. Some argue nuclear is needed to significantly cut emissions, others argue it's too dangerous. But that's a whole nother topic. This gets into an interesting intersection, as many people who are environmentally concerned in the US are on the left, but most of this group seem to not want either nuclear power and tend to disagree with fracking. There's a lot of emphasis on solar panels and wind farms, as those are seen as more green. Here in the US, the Green New Deal was the most recent large-scale motion put forward to combat climate change. According to factcheck.org, estimates for the cost of getting the US to net zero emissions by 2050 range from $18 trillion to $93 trillion. If this plan was enacted over the course of 30 years, the price ranges from $0.6 trillion per year to $3.1 trillion per year. For reference, here's the US federal spending by year, where in 2020 the US spent $4.8 trillion. And also for reference, here's the current US national debt, which in 2019 was sitting at $22.7 trillion. So, in order to meet the zero net emission standard put forth in the Green New Deal, as best as I can tell, it would cost anywhere from 11% of the current US federal budget per year up to 39% per year. And if China and India, as well as other large emitting countries, reverse course to do the same sort of drastic actions to reduce emissions to net zero, in 80 years the world would be potentially 1 degree Fahrenheit cooler than we think would happen if we didn't do more than we're currently doing. So, if the US did its best and other large countries did nothing to lower emissions, would it be worth it despite not changing the temperature outcome? If the US led in reducing emissions more aggressively, would it accelerate other countries to follow? Could money be better spent on research and development to find a profitable way to lower emissions? And are other energy options, such as fracking and nuclear power, worthwhile alternatives? If we're going to have a meaningful discussion on such a broad topic as climate change, all of these things need to be taken into account. I think we have a responsibility to take care of the planet we have, and I think many people are doing a great job of this. The question is, how do we go about fulfilling that responsibility further, and what are the trade-offs for each solution? As always, thanks, hope you enjoyed. And if you did, consider subscribing and hitting the bell so you'll get notified for new uploads.